Alright everyone, so welcome back to my channel. Today we're gonna solve a problem called search in the rotate sort array. This is an interesting problem and it's require you to know the binary search. So in regular binary search, you just have to get the left pointer and the right pointer, and then you find a middle. If your middle is not equal to the target, it's not gonna be, we're gonna shrinking this window by half by moving the left pointer or the right pointer. So if you don't know about binary search, I highly suggest you to learn about it before solving this problem. This problem is a little bit different because let's have this number right here, 0, 1, 2, our first example. This one has been rotated, meaning that this position right here, 0, is at this index and it formed 0, 1, 2, 1, 2, 4, 5, 6, 7 right here. So it's still in sort, but it's just been rotate. Like this one is gonna be a circle like this, but it doesn't matter. It's just been pivot in at the point. So this point right here is the pivot, right? You're still gonna have your left, you're still gonna have your right pointer. And first question is, this is on the right, this is on the left, right? So the first thing you need to ask is, how do I know if I have my M, the middle part in here, right? Is this M is belong to the left side or is belong to the right side? Okay, in order to know that, you can either use the right pointer right here or you can use the left pointer right here. Either way it's work, but right now I'm just gonna use my left pointer. So let's say if arbitrarily my right is at this index, right? And the value is 0, 0 is smaller than the left, right? So 0 right here, because this is middle, it should be bigger, but right now it's smaller than the left. It meaning that this M pointer is on the right side. So just in case, in the other case, if middle pointer is in the 6 or 7 right here, is greater than left. So that is where I know if the M pointer is on the left side or on the right side. Now, let's say right now my M pointer is on the left side, right? The only question is, do I move my left or do I move my right? How do I know that? I will take my target to do that. So let's say I have another variable called target right here. I will just check, right? If my target is in this range, right? If my target is in this range. So if my target is 5 or 6, whatever in between the 4 and the 7, I know exactly that is on the left side with the M. So in that case, I'm gonna move the right to here. In the other case, if my target is not falling into this range, I'm just gonna move this to this side, right? Even the M pointer is somewhere right here and my target is somewhere here. 7 is not falling in this range and I move the left is also correct, right? So that would solve the case. What is the other case? My mid pointer right here is in the other side. So exactly the same thing. I would just search if my target is in this range, right? If it's in this range, we move our left. If it's not in this range, we move our right. So basically we have two if statement. We just have a double statement inside regular binary search. So let's try to code it up and see what happened. So right now, let's see if I on the good. So I have my length right here. It's gonna be equal to length num. I have my left pointer is 0. I have my right pointer is gonna be length minus 1, right? So I have a standard binary search right here. So left and right, right? This one should be capitalized. I don't know why I'm doing that, but I have my mid pointer, which is equal to left plus right divided by 2. If my nums of equal to the target, which means that we found our target, we just need to return M. That our mid pointer, and then in here it say if -1, it means that we are not finding our nums. That K is where we out of the loop right here. So now I'm gonna check if the mid is in the side, right? So if it is the mid left side, it's gonna be nums of m is smaller. Oh, the num of n is greater or equal to num of m. Right, so this is greater or equal to the left side. It means that it's on the left, right? So in that case, our nums m must falling into the range, right? So fall into range of if my right. So left is falling into this range. So our target should be falling into the range of left and right. So nums of mid right here. So if that's the case, we move our right -1. In the other case, we move our left m+1, right? So other case is when it's on the other side. So m smaller or equal to left, right? I'm just gonna copy and paste just to make it quick. And in here, it should be in the so this is when it is on the right side. I check that if my target is falling into the right side between the mid and the right. If it's on that side, we have to move our left. And if it's on the other side, we move it to the right. And this should be end up good. And let's see, yep, it's good. And yep, it's also good. So the time complexity for this problem is gonna be O of n. So O log n, the time complexity, and the space complexity is the solid O of 1. So be O of 1. Let's comment this out and it should be good. Alright guys, thank you for watching and see you soon on the next video.